You asked and we're answering. Whether you attended one of our PADS Professional MCAD Collaboration webinars live or watched the recording on demand, some great questions were asked. So let's get the answers. Hi there, I'm John McMillan, and welcome to this special series of PCB Tech Talks, the After the Webinar podcast series. In this special podcast series, I'll be joined by webinar presenters and we'll be answering and discussing the questions submitted by attendees. As always, be sure to subscribe to this podcast, let us know the topics you'd like to discuss, and if you'd like to be our guest right here on PCB Tech Talk. Today I'm joined with the webinar demo presenter, Brent Klingforth. So hi, Brent, and welcome to PCB Tech Talk. This is the After the Webinar series. How are you doing today?
I'm doing pretty good. Webinar was really good. We had a lot of attendees. The topic was one that's very well needed in the industry and people requested. So it was good.
Yeah, it was great. Before we get started with the Q&A, why don't you give us a little bit, just about your background in the PCB industry?
All right, a little bit about my background. I started working for a small tape drive company back in the 80s, moved into R&D, started doing PCB design in the early 90s. So I've been doing printed circuit board design since about 94 timeframe. Went and worked for a startup. I then moved over to HP, worked there for a while. And then I started working for a reseller at 2000 where I, demoed PADS and Expedition and DX Designer and all those products. And just recently, in the last 4 or 5 months, I've joined Mentor as a technical marketing engineer with my 20 years of PCB experience. It's bringing a lot of good insight.
So do you have a favorite project in your career so far that you've worked on that you think is pretty interesting?
Yeah, I was doing some PCB consulting actually during my time frame as a reseller, and I did a couple board designs that were very complex. I did them in PADS layout, and between working with the engineers and me and my experience in PCB design, the boards came out perfect the first time. They had a lot of very high speed gigabit Ethernet or data transfer signals in it, and I was very pleased the way the boards came out. In the end, there were 2 or 3 of them that I did for this company, and they all worked the first time.
That's awesome. So before we jump into the questions, why don't you just tell us just a little smidge about what you like to do for fun when you're not in the EDA world doing your T&E work?
That's right. Yeah, my hobby is rather interesting. I'm pretty dedicated to it. It's RC car racing. I race little 10th scale and 12th scale remote control cars on a competitive level, locally and at national races.
Are those gas or are they electric powered?
There's both, but I only race the electric. They're LiPo battery powered with brushless motors, electronic speed controls. They're pretty high tech little cars, actually, even though they look like a toy. They're fairly expensive and pretty high tech.
That sounds fun. Is there any PCB designs in any of the work that you do there? Or is it just do you ever design any of the controllers or anything like that?
No, I haven't gone down that road, but I've definitely critiqued some as I've seen them and taken them apart. But I haven't gone off and designed any myself. In that case, I wish I could, but I just haven't had time and resources to do that. Gotcha.
We're all pretty busy.
Yep.
So let's start jumping into some of the questions. We're going to revisit the questions, the Q&A that we answered during the webinar series, because they're not actually part of the on-demand webinar. And in addition to that, the ones that we did not get to during the webinar session, we're going to go ahead and address those too. I'll start out. One of the questions we were asked is, in the webinar, we mentioned supporting other MCAD tools other than NX. And what were those tools that were supported? And the answer to that is, in addition to Siemens NX, and the MCAD Collaboration's real-time data exchange is also supported by PTC Creo, SolidWorks, and CATIA. So Brent, there was a question, where does the tool get the 3D step model files for components that are used by both ECAD and MCAD?
Yeah, so there's a lot of places that data can come from. Obviously, as a company with mechanical engineers, you can create them internally if you like. But the best place to get them is like from a vendor's website. A lot of vendors, especially like connectors and kind of odd parts that are more mechanically inclined, you can download those from their vendors. They'll give you step files, IGES, all the different file formats. But there's also a lot of websites you can go to and get that content for free. One of them, Trace Parts, I think it's 3D Connect, is rather large for free content, but that's where people generally go look for stuff to download. On top of that, you can go to our PartQuest tool, and if you download components from there, several of our components now are coming with 3D models, and that's going to continue to grow as we move on into the future. So for electrical parts, even PartQuest should be like your first place to go for 3D models for parts.
Yeah, good point. PartQuest, you can download the schematic symbol, the component land pattern, and like you said, it's rapidly getting all the 3D models in there as well. The next question is the MCAD Collaborator an additional cost, or is it included with PADS Professional? I'll take that one. For PADS Professional, it is part of the PADS Professional tool suite. So you get it with it at no additional cost. It's not an add-on.
I think another question we had was how our models moved between the ECAD and MCAD environments. So
right, that was a big one.
Yeah, that's kind of a big one, and we have a good solution for that, at least, especially if you're using the NX tool. But once an electrical engineer has placed all that 3D model content in a design, they can obviously put it into their library so they can reuse it over again in future designs, which is very helpful. But when we transfer the IDX data to, say, NX, we have an option to output model data for NX. Currently, it only does support NX. We'll be bringing Solid Edge on board here in the near future. But you can export all of the model content out of the design. So now when you go over to NX and bring in that IDX file, it'll automatically bring in all the 3D models and everything associated with it, saving the mechanical engineer a tremendous amount of time in dealing with all the parts that you put into your electrical design. So that's an advantage there. With other tools, say SolidWorks, CATIA, the mechanical engineer will have to create or have a library of parts and then create a cross-reference file that says, here's the part name coming across in the IDX file, here's what to go grab in their library. It'll then bring that in, and then really the only concern there is to make sure the rotation of the part in the X and Y and Z and the center point is the same between your PCB model and the mechanical model. And then everything will work seamlessly.
That is a good advantage. The next one, can collaboration be driven from the PCB design versus from MCAD? Normally when you see MCAD collaboration tools, they are driven from marketing or form fit and form factor and all these kind of things for end product users. It's got to be in the best shape. So you do see it driven from MCAD most often, but you absolutely can. You can create a baseline and drive it from the ECAD side. I mean, imagine you're creating the next Raspberry Pi card, and as your design grows, the form factor grows, and you decide you want to put that in an enclosure after, you could absolutely begin a collaboration session from the ECAD side, then start collaborating with MCAD back and forth.
Yeah, and along the lines, I think we got another question about what if my tool doesn't support the IDX format? Like there are tools out there that haven't grasped onto this industry standard of ProStep. You can take a step model out of your MCAD tool. So I could like draw the enclosure, or the mechanical engineer can still draw the board outline. They can place mounting holes. They can output a step model. And then we can bring that into PADS Professional, the step model, and we can convert the faces of that step model and the holes into an actual object. So you're still saving a tremendous amount of time, even if you're not using NX, Solid Edge, SolidWorks, CATIA, one of those more mainstream tools for getting your work done quicker.
Another thing worth pointing out from the presentation, and Brent, I'll let you elaborate on this, is we essentially showed two really great capabilities, and one was collaboration, and another one was co-design. So even if you aren't collaborating with an MCAD partner, you can still use the co-design part, right, Brent?
So yeah, you're not limited to having to do the collaboration. With PADS Professional, you can bring in, say, an enclosure from the mechanical engineering team. So they could output, say, like in our demo that we showed in our webinar, a heat sink from the drill that we were using. But it could be any enclosure that PCB is going to sit into. There's no limitation on size. You can bring in multiple step models as well, and you can align that mechanical feature with the PCB. So now I can place connectors based on holes and openings in the board. I can align my mounting holes with the mounting hole spots in the board. But more importantly, and this is where the real time savings and high quality design comes from, is I can do three-dimensional DRC checking. So if there's any overhangs on the board, if there's any areas of the board that have height constraints, I can see all of that visually and make sure I don't place parts in that area, so we don't have issues going into manufacturing. And again, on top of that, I can put tolerances on my DRCs. So I don't have to have just a collision. I can see, oh, I'm within 10 mils, I'm within 5 mils, I'm within 25 mils. Those requirements can be checked in the design using design rules that you set up. So that's a very powerful capability of that co-design feature capability that you're talking about, John.
Yeah, I think that there's a lot of advantages to that, because it enables the PCB designer to bring in, like you said, a heat sink that may be bigger than the actual component it mounts on, and you may not even realize that it had like a collision with a close by component or a header or something like that until it's assembled, right? I mean, and that's the wrong time to find something out after you've fabricated a board and you're putting it together.
Yeah, or you spend time building prototypes to find that stuff out. I mean, we're in an age now where everything should be digital. We should be doing things virtually in our tool, and when we produce the end product, it's right the first time. We don't have to worry about wasting time building 3D printing stuff or getting prototypes built just for fit and function purposes.
Yep, very competitive market we're in right now, no doubt. So next question is, how does the collaboration tool receive and send the data exchange files if the tools aren't connected? That's a great question. A lot of companies, they may have an ECAD team and they may sub out the MCAD design to a company that specializes in that. They could be across the hall, they could be in the same state, across the nation, or in another country. So how are they exchanging this? And the tool has a built-in file watcher. This file watcher enables you to send and receive exchange files. As soon as you launch the Collaborator, they'll be present. You'll see them right there. It can be set up in several different ways. It can be done by email. It can be done by a shared server location. It could also be a shared Dropbox location. So there's multiple ways to utilize this data exchange file. And as I said, it'll automatically, once you launch the tool, you start up the tool the next day, you can launch the Collaborator and you'll be able to see all the collaboration requests right there in the console.
Yeah, that is a very powerful feature of the tool, is you're not locked into being on the same network. The data can be shared in many different ways, even via email. So
Yep.
So a question was asked about, what if I'm doing like thermal simulation and I need to get electrical data from the PCB in my MCAD tool? Can this be done via IDX or even step files for that matter? And yes, it can. We do transport all the copper information in the board, silkscreen information, solder mask data in an IDX file, and you can bring that in to your MCAD tool, assuming the MCAD tool supports that capability in the IDX file, which in this case NX does. I showed that again in the webinar, that I can bring in all the plane areas, all the traces, everything, and then the mechanical engineer can simply set up his models for his components, do his meshing, and move on into simulation without having to create anything or use what if type scenarios for, oh, this is just one big copper plane. They now have all the individual planes, the stitching vias going through the board, all the cutouts and holes in the planes. It's as if the board you were sitting there in real life looking at the board and doing testing with it. So that's a really big advantage for those that have a lot of thermal concerns with their design is using the collaboration capability for doing that as well. So I think we had another question related to flex design. Can the flex information be transported through collaboration? So yes, PAD Professional has the capability of designing a board with flex in mind. So you can produce all your areas in our 3D environment. You can even go in and fold the board and see how it's going to mesh with the other board that it might be folding up against. But that information can also be transferred through collaboration, and the mechanical engineer can then take that into his design, and then he can fold the design in the way it's going to fit inside of his enclosure. But just remember, I can bring that enclosure into PADS Professional, and I can do a lot of that as well as the electrical engineer, the PCB designer, again, trying to eliminate time delays in waiting for the mechanical engineer to make a decision when what I'm doing can be based off that mechanical enclosure as well. So yes, the capabilities there, but try to remember, take advantage of it yourself using the 3D capabilities in PADS Professional.
Well, I've covered all the questions I have on my list. How about you, Brent?
Yeah, I think that was it. We had a lot of good questions. I want to thank everyone that did join the webinar and asked some very good questions, and hope it was a big benefit to everyone. And we look forward to hearing more from you in the near future.
Yeah, and thanks for joining me today, Brent. I really appreciate it. Oh, I have one more question. Will there be an archived recording version of this presentation? And for those who attended, I think, or registered for it, yeah, I think it already is ready on demand. Otherwise, I'll have a link to it in my show notes. Thank you, Brent, and thank you for joining the first in this special After the Webinar series podcast. For more information on this podcast, as well as a link to the on-demand replay of the webinar discussed, be sure to check out the show notes. There, you'll also find additional information related to this podcast, along with my email address. So feel free to send me your comments and questions, or any topics you'd like to hear me talk about, or if you'd like to be my guest right here on PCB Tech Talk. I'm John McMillan. Thanks for listening, and be sure to subscribe to this podcast on iTunes, Spotify, or your favorite podcast app, and be sure to catch the next episode of PCB Tech Talk.